This video is going to take you through Student Learning Task 7, graph, sine and cosine as functions of real numbers, and identify key features of the graph. This lesson is going to start on page 14 in your packet. We're just going to review some key vocabulary we did in topic 1, introduction to the unit circle. We're going to go back to our friend, the Ferris wheel, where we graph time and height. Remember, this was our starting point here on the far right, and at that point at 0 we were at 30. It made a whole rotation in, it looks like about 20 seconds. It was back there because here we are at the top at 5 seconds. So like this was 5, then we're back at the middle at 10, and then 15, and then 20. Number 1 says the center of the wheel is 30 meters above the ground. How does the graph reflect this? And the answer is the midline is y equals 30. The radius of the wheel is 25 meters. How does the graph reflect this? Well, here's our midline. Everybody dot that in at y equals 30. So the radius of 25 meters from the midline to the top, that's how I measure my amplitude, is 25. So how does the graph reflect this? The amplitude is 25. A wheel completes a full turn every 20 seconds. How does the graph reflect this? The period is 20. So on your graph, maybe kind of like shade in one full rotation. It starts in the middle, it goes up, it comes all the way to the bottom, it comes back to the middle in 20 seconds. Then you can kind of see, I'll switch colors. We have a second period from 20 to 40. That's our second period. Okay. So now we're gonna get a little more involved. The line shown below is called the midline of the wave. The midline is a horizontal line that lies halfway between the minimum and the maximum of the wave. What is the midline of the wave of the graph involving the Ferris wheel? So we've already done this. That would be y equals 30. Now, what is the equation of the midline of the graph of f of t equals sine t? Now, what I want you to do is I want you to go on your calculator and we're going to change some modes. I want you to make your mode as follows. I want you to change your mode to radians. So, see, this graph is this calculator is in degrees. I'm going to switch it to radians. Then I'm going to go to y equals, and I'm going to type in sine x. And I'm going to hit zoom trig. Okay. And what that does is it kind of sets up this graph from 0, and then on the far right this is 2 pi, and on the far left this is negative 2 pi, and then each one of these little marks is pi divided by 2. So what is the midline of this graph? It's going to be y equals 0. If we switch the sine to a cosine, it also has a midline of y equals 0. Remember, at any point you can always pause the video if I'm going too fast or if you need to rewind and see something again. Alright, the distance shown below is called the amplitude of the wave. The amplitude is the distance between the midline and the maximum. So again, like just from here to the top, that's the amplitude. What is the amplitude of the graph on page 1 involving the Ferris wheel? So if we go back here, we see that the amplitude is 25. What is the amplitude of the graph f of t equals sine t? Well, if I go back and I change my calculator to just sine, I see there's the midline at y equals 0, and this graph is only going up to 1. So it has an amplitude of 1. And cosine also has an amplitude of 1. The distance shown below is called the period of the wave. The period is the smallest value of k for which f of t plus k equals f of t. So in other words, like, and you have to be careful because it's this value is the same as this value, but we really mean like one whole cycle. See how these little arrows from here to here? That's one period. All right, so on page 1, the Ferris wheel problem, the period was 20 because it was one cycle in 20 seconds. Now, what is the period of sine t? So if I take my calculator and I turn it back to sine, it starts here and it goes all the way to the end. Now, if you are in radian measure and you have pressed zoom trig, this should be 2 pi. Now remember, pi, second, you can't see that, second, and then you get it by second power is 3.14. So 2 pi is like 6.2. Now, I'll be honest with you, this aggravates me. When I press window after pressing zoom trig, why isn't this like 6.28? But you'll see that this x scale is pi over 2. So I don't know why it cuts you off by like one little pixel. But we can see that we've got from 0 to 2 pi is one period, and from 0 to negative 2 pi we have another period. All right. Number 9 says, what is the period of the graph g of t equals cosine t? Draw 2 arrows on the diagram above to show one standard cosine period. So if I take my graph and I switch it to cosine, I see this graph. So I have to look, and I can see one cycle starts up at the top and it kind of comes down. So imagine like if you started at the top of the Ferris wheel and then you went down to the bottom and then you came back up to the top, that would be one period. So that's still 2 pi. Let's draw that on the picture. So here, like if I started at the top and I went here, this is one period of cosine. And you can kind of see, like, if I take this little piece of the graph and I were to like redraw it over here, that would be like a second period. All right, so your assignment now is to work on page 16 and 17. I'm going to do a few with you. What I would like you to do for each graph is to state the amplitude, the period, and the midline. So when I look at number 1, I can see that it's kind of like symmetrical around the x-axis. Like when I go to look for the middle, the top looks like it's at 10, and the bottom looks like it's at negative 10. So I think the midline, let's start with that. The midline is going to be y equals 0. The amplitude from the center to the top is going to be 10. And the period, well, see, I can kind of see it looks like a cosine function. And from here, that's one period from top to top. Cosine period is almost easier to see. One cosine period goes in 4 pi. Okay. Let's look at another one that maybe looks kind of tricky. Let's look down here at number 5. So what I want you to do is to sketch in the midline for number 5. Hopefully you sketched in, you saw like there's a point here at 1 and 1 at 5. And in the middle of 1 and 5, you sketched this in, and that's our midline. So the midline is y equals 3. Now once I have the midline, I can see that it goes from 3 to 5. So the amplitude is going to be 2 because 1, 2. Now the period. This looks like a sine graph. It starts here. Let's trace. Goes up, goes down, back to the center. That's kind of hard. I can't really see where it is. That's not so clear. Let's look at where these 2 dotted lines are. If I look at it like a cosine graph, it starts here. Get more of a contrasting color. Oh, the red. And it goes from here to here between these 2 dotted lines. So it goes from pi over 6 to 2 pi over 3. Now I'm going to teach you a trick. I need to subtract these two values. I need to do 2 pi over 3 minus pi over 6. What I'm going to do is I'm going to grab my calculator and I'm just going to do 2/3 minus 1/6. That's a terrible looking 3, but whatever. So I'm going to do 2 divided by 3 minus 1 divided by 6. Math, enter, enter. And it's pi over 2 because I just kind of ignored the pi. And this is 1/2, so this is going to be pi over 2. That one's a little tricky. Period. Pi over 2. Like when I look up here at number 3 is a lot easier because I can see it starts here, goes here, and that's just pi. So that period for number 3 is pi. That one has a midline of y equals 0 also, because it like goes up here to 3 and goes down here to -3. Midline is y equals 0. The amplitude is 3. So let's look at number 2, and then maybe I'll leave you to your own devices on the rest. But I want to point out, like, this number 4 is kind of hard to see. Here's the x-axis. So number 2, I see I've got a point here at like -1, and I have one here at -7. So the middle is going to be here at -4. So midline is y equals -4. And then I'm going to count 1, 2, 3 from the midline up. Gives us an amplitude of 3. So this one's pretty straightforward. It looks like a cosine, starts at the top, goes down, comes up, and my x value here is 4. So the period is just 4. So go ahead and finish the rest of pages 16 and 17 for homework.